Alright guys, so we're going to be taking a look at an FRQ from the 2005 AP Calculus test, Form B. And it says, a water tank at Camp Newton holds 1,200 gallons of water at time t equals 0. During the time interval where t is between 0 and 18 hours, water is pumped into the tank, which is modeled by W of t. During the same time interval, water is removed from the tank, that is represented by R of t. So the first thing that we can do is put these functions into our calculator. So y sub 1 will be W of t. And y sub 2 will be R of t. Now we can go ahead and go into part A. So part A says, is the amount of water in the tank increasing at time t equals 15? Why or why not? So let's go ahead and start writing. Part A, t equals 15. And for the total rate of the total amount of water in the tank, we will represent it by W of t minus R of t. And now we can go to our calculator, second window, make sure it's on ask, and second graph, input the value of 15, and we will get our values. So at W of 15 we have 131.78, and R of t is 252.87. And from here we will go ahead and simplify that. We have negative 121.09. So now we can answer the question. At t equals 15, the amount of water in the tank is not increasing since negative 121.09 is less than 0. And now we can go ahead and take a look into part B, which says, to the nearest whole number, how many gallons of water are in the tank at time t equals 18? So part B, t equals 18. And the function that we will be using to represent this is the integral of the total amount of water, which is W of t, minus R of t, dt, from 0 to t. And we can go ahead and put that function into our calculator. I'm going to go to vars, now that we have the function put into our calculator, second graph, put the value of 18 and go to y sub 3. Takes some time, and the value that we're given is 109.79. And now whenever we look back at the question, it says that at time t equals 0, there are 1,200 gallons of water. So we can add that value. And we are given 1,309.79 gallons. And that's how we answer part B. So part C says, at what time of t between 0 and 18 is the amount of water in the tank at an absolute minimum. Show the work that leads to your conclusion. So let's go ahead and put part C, and we are looking for the absolute minimum. Now for this, we're going to have to find the critical numbers of the function, and that is where W of t equals R of t. So let's go ahead and go to our function. Now here you have the integration of the amount of water in the tank, so you can go ahead and turn that one off. We'll go ahead and graph. Let it load. Okay, so over here we can obviously see that we do not see the function, so we'll go to zoom, fit, let that load. And here our window is showing the x value from -10 to 10. And in the question we are looking for the interval from 0 to 18. So let's go ahead and change those values. The x min at 0, x max at 18, graph. Here's the first one. Now the critical numbers for this function are represented by the intersections of the two functions, and here we can see that we have two intersections. So let's go ahead and find what those values of t are. Do second trace, intersect, first curve, set right here, guess. And the value of t with the intersection is 6.4948. Now we can see that we have the other intersection, so let's go ahead and second trace, find that value. Second curve, and guess. The value of t is 12.9748. So these are our two critical numbers, but if we go back to the question, we were looking for the absolute minimum. So we'll have to find the value for t equals 0 and t equals 18. So for this, we're going to be using our function g of t, representing the amount of water in the tank at any given time. And we will have to find g of the first critical number, g of the second critical number, g of 0, and g of 18. So let's go ahead and go into our calculator. Second window, make sure it's on ask. Second graph, put in your first value. Second value. And then go ahead and put the values of your interval, which are 0 and 18. Go to y sub 3, and we'll get our values. Okay, so for g of 6.4948, we have 525.24. For g of our second critical number, we have 1,697.4. G of 0 is 1,200, and g of 18 is 1,309 6.8. The question's asking for the absolute minimum, so obviously our lowest value of g of t is at t equals 6.4948, so we can conclude that the absolute minimum of water in the tank is at t equals 6.4948. And that's how we solve part C. Let's go ahead and move on to D. And D says, for t is greater than 18, no water is pumped into the tank, but water continues to be removed at the rate r of t until the tank becomes empty. Let k be the time at which the tank becomes empty. Write, but do not solve, an equation involving an integral expression that can be used to find the value of k. So for this, we know that after t of 18, water is still being removed at r of t. So remember r of t. And we also have to know the value of, at 18, the total amount of water that's in the tank, which we answered that in part B, and that value is 1,310. And from that we'll have to subtract the amount of water that is being removed after t of 18. That's represented by integral of r of t dt from 18 to k. So now this is the function that is representing the value of k, which is the, okay, I got like lost there.
You can start after writing out the equation and explaining what the equation is.
Okay.
It's basically the equation of the amount of water being removed after t equals 18.
Okay. To start. Okay, so this function is representing the amount of water that what did you say? Where do you want me to start?
No, because the question is asking you about writing out an equation of the amount of water being pumped out after 18. T equals 18, right?
Yeah.
So that is the model
Okay.
of the function being pumped out. Because you already formulated the function.
Okay.
The integral function.
Yeah.
So you're just explaining what it means.
Okay. Okay, so the function right here models the amount of water that is removed from the tank after t equals 18. And we'll have to equate this to 0. Go ahead and do your simple algebra skills. Add on both sides. And this is the function that represents the amount of water that's being pumped out of the tank after t equals 18.